And here we go. We have liftoff.
Propulsion continues to be nominal.
RCPA chamber pressure looks good.
Following up. Roger, roger, planet.
Water towers fly! Yes!
Payload down to nominal.
Flight downside FD off. Bring in FD off. Off. It's orange!
Oh my god! Oh my god!
Decollage. Put that in the big bag, Signal.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
The methane will be igniting in the flare, correct?
Yikes. You good? Sure. We don't need any more of these.
Good evening/morning. You are taking a live look right now at Space Launch Complex 41 at the Cape Canaveral Space Force Station, where United Launch Alliance is set to launch 27 satellites for Amazon's internet constellation, formerly known as Kuiper, now called LEO. I am Sawyer Rosenstein, and I will be your host for this evening's countdown to Atlas. As is always the case, though, I am not alone. I have the amazing Florida field team joining me as well, including Max Evans. How's it going, Max?
I almost said good evening, but it is technically morning now. So good morning, everybody. A very, very early morning. And it is not your ordinary Starlink, as you like to say, Sawyer, but it is another set of internet satellites going into low Earth orbit aboard in Atlas V this time. So I am greatly excited for this one.
Oh, yeah, especially as the number of Atlas flights start to dwindle down, they all get that much more exciting. And also joining us from the field today is D Wise. D, how are you doing?
I am doing really well. You know, it is a beautiful early morning. We've got calm air, skies full of stars right now. So it is a beautiful, very early morning and a great day because we are looking forward to a launch. It's definitely not your ordinary Starlink today.
That is true. But is it your ordinary Kuiper launch? You'll have to wait and find out.
It's not. It's a new name. It's Amazon Leo.
Oh my god, that's the first one of the day. We were joking before that we're going to need a counter for the number of times that we mess up calling Leo by its old name of Kuiper. So, yeah, those are interchangeable of what it was. So, this was originally going to be KA-04 for Kuiper Atlas, but as you can see in the top left, this mission is called LA-04, now for Leo Atlas 04, or as I just call it, LA-04. And yeah, that is the new logo. And I mean, D, you were out there when setting up remotes and everything. Those are not just purple dots, right?
No, they are not. So I was mostly setting up. I didn't get this shot. I believe this one would be Max's shot. But if you look closely, it is the letters LEO, which is very fitting for the constellation here. And you know, it's really cool. And this is a sort of art we don't often see. We're used to seeing maybe like the mission patch art on fairings, and with Falcon 9s, that's really rare. Atlas, it's far, far more common. But this sort of more advanced fairing art is really cool to see. I really like it.
It's certainly one of the more unique ones that we've seen painted on those fairings, that's for sure. And I mean, ULA is famous. There was a person, I think there's videos of it online, of the one person whose sole job it was to design and paint all of the fairing art for ULA. I wonder if they're the same person that helped with this design too, because that is a lot of intricate detail for all of those LEOs.
It really is. This might be the most ambitious and creative fairing art that we have yet seen on an Atlas V to this point. Normally, it's either like a logo for like NOAA or the Space Force or for Viasat, whoever or whatever other commercial customer is being flown that day. But obviously today it is Amazon, formerly known as Kuiper, now Leo, and there's a bunch of small lettering, very finely painted onto it. So cool to see, but also kind of unique. I think unique is the best way to describe it.
Yeah, especially because if it's spelled wrong, you either have the Electric Light Orchestra or you have LOL. So
I was just gonna say, if you read it from north to south or up and down, it's LOL at times.
Oh, it's just a fun little fact there. One of the joys of seeing this new fairing with the new name on it. But while it may be a new fairing design and a new name for the satellites, it is quite an old, reliable rocket with Atlas V in the 551 configuration tonight. So that means you have 5 of the GEM 63 solid rocket boosters. You have the 5-meter fairing at the top and 1 singular Centaur upper stage engine. So, Max, for people that actually have clear skies for it tonight, this is a rare treat for the East Coast of the United States. Do you mind talking us through the trajectory on this one?
Yeah, absolutely. So, for one thing, it is unique to have an Atlas V launch at night because over the past 3 to 4 years, that has been a rare occurrence. But this is the second one in a row to launch at night, so I guess not so special anymore. But it is special in a way because there are only 10 Atlas Vs total remaining to launch, including this one. But in terms of trajectory, this one is going to be going northeast on a 51.9 degree orbital inclination, heading up the east coast of the United States. So if you are in Georgia, South Carolina, North Carolina, Virginia, maybe even in DC or New Jersey out there, depending on light and weather conditions, you may be able to get a look at the launch tonight, depending obviously on where it may be in the sky and the atmospheric conditions around you at the time. I think Centaur might be a bit more tricky to spot because, of course, the exhaust from the its hydrogen fuel isn't as bright as the RP1 and oxygen mixture that we see on Falcon 9's upper stage with the singular MVAC, but you never know. But we are still too early in the morning to hope for any kind of jellyfish effect with either the first stage with the boosters or the RD-180 or even the upper stage as well, unfortunately. So if anybody is up on the East Coast and watching tonight for liftoff and you happen to grab any photos or videos, please feel free to post it on X or Facebook or any social media really, and please tag all of us. We would love to see it and maybe even feature it on stream if you post it fast enough. So, but yeah, it'll be going northeast, similar to what we see with Starlink missions, albeit at a slightly lower inclination. But that is where the LEO satellites are going, and I believe. Let me get my fact sheet back up here. Standby caller. I think they're heading off to they are. So they're heading off to a 450 kilometer altitude. So just a bit bit lower than Starlink usually is as well. But such is the case. I mean, obviously we were just talking about it before stream. There are only 4. Is it including this one or not? No, I think it is.
Not including
this one. Not including this one. There are only 4 more Atlas Vs left that are non-Starliner equipped Atlases. So that means there are only 4 more left for Amazon's LEO constellation, at least aboard Atlas V. They will be launching also aboard the Ariane 6 and Vulcan, ULA's other rocket, and also New Glenn as well.
Yeah, and a reminder, Amazon does have a deadline to meet. They need to have at least half of their constellation up in orbit by July of this coming year. So they are scheduled to have about 3,200 satellites. They need about a little under 1,800 of them, I believe, or 1,700-ish, to go by July, or else they run the risk of losing the bandwidth that they had purchased to use. So we'll see what happens with that. It's going to mean a much higher launch cadence, too.
Which we so far have already seen from Atlas V, which has been a nice treat considering how little ULA has launched in the past couple of years alone, especially in comparison to other providers out here on Florida's East Coast, not to mention names. But seeing Atlases fly as often as they have is a real treat. But that means the faster they are launching, the faster it is going to go away for good. So, it's great to see, but also kind of sad in the afterthought. But that is how it goes sometimes.
That is how it goes. Yeah, all good rockets must come to an end at some point. We had Delta IV what was it, last year end, and now we're coming up to the end of Atlas.
Indeed.
It's like the end of an era almost. And if you have any questions, by the way, about anything to do with tonight's launch, with Kuiper, number 2, with Leo, with Atlas 5, any of those questions, tag us at NASA Spaceflight or at NSF, and we will do our best to answer as many of them as we can. Just don't at Kuiper, okay? So, D, I think D's working on the camera really quick. So, as UMAX, recovery assets downrange. I know it's a long list, right?
A very long list. And the list being literally 0, because of course Atlas 5 is a fully expendable launch vehicle. So all 5 solid rocket motors, Atlas's core stage, and Centaur will all be tossed into the ocean along with the fairings as well, unfortunately. So Atlas is a very reliable rocket. It has a 100% success rate to this point, albeit with still 10 left to launch. But it has... I don't want to use the word bulletproof because that not only gives bad juju, but also I don't want to jinx it as well. But Atlas 5 is very, very reliable, but at this point it is also very, very old, having flown first. I think it was in 2000. Oh goodness, 2 or 3. Somebody fact check me on that. I could be wrong. But either way, it has flown for a very, very long time and it has changed very, very little. So a bit sad to see it go, and it is a bit of the last remaining rockets flying here on Florida Space Coast that are, I guess, quote unquote, of the old space era. But obviously, it works, and that is why customers keep coming back to it.
And it was August, of 2002. You were right.
2002. Okay. Yeah. So it's been flying for a very long time. Obviously, it has undergone changes. It has gone through a slightly differently sized fairings with different materials. It has gone through, I think, 2 or 3 different sets of solid rocket boosters. I think it's 2. First, they were on the AJ-60s, and then they moved to the GEM 63s. That are just a bit bigger than those as well, and then the GEM 63 XLs actually fly on Vulcan as well. So it's gone through a bit of evolution, but more or less it is exactly as it was about 24 years ago now.
Yeah, the biggest thing with the improvements to it was making it part of what was called the EELV program, the Evolved Expendable Launch Vehicle, which is a way that is meant to be able to launch a whole bunch of stuff while being relatively cheap to then throw away afterwards, hence the expendable part.
And to show you just how long this rocket has been around, obviously 2002, but that to add more context to that, the other rockets that were flying at that time include the Delta IV family of rockets, and also Delta II, which was retired back in 2018 itself. So Atlas is the last of an era, going all the way back to the 1950s when Atlas first began as strictly an ICBM program for the U.S.'s defense initiative. So obviously not that anymore, and its construction has changed quite a lot since then. But yes, Atlas is the last, I guess, of the final bastion of old space hanging around.
Yeah, especially as most companies now move towards the reusable side of things, or at least partial reuse. Almost every company is working on that now. Whether it's operational yet or not, that's another story, but it's being worked on at least.
But Atlas works, and it is reliable. So it has those 2 very, very, very important points going for it.
Yeah, I believe Tori Bruno, the CEO of ULA, continues to tout its perfect record, basically, as part of ULA's rocket fleet. Here's one from Mabel asking, do we know how many satellites are on board? And Max, how does that compare to what we're used to seeing for Starlink?
Well, so normally we see anywhere from 26, sometimes up to 29 Starlink V2 minis on Falcon 9 nowadays, especially from here on the Space Coast. Usually it is around the 28 to 29 amount. But today there are 27 Kuiper satellites aboard Atlas 5. And of course, because of the weight of all 27 of those, and these satellites are not small either, that is why they need all 5 solid rocket motors to reach its targeted orbit and altitude. So they weigh quite a bit. I don't have the numbers off the top of my head here. Let's see. I'm not quite sure on the exact mass per satellite. Maybe I can get Alex here in the back channel helping out on that front. But obviously, these satellites are big and they are heavy, and there are 27 of them crammed inside of that 5-meter payload fairing on top of Atlas 5. So that is why it needs all 5 motors. And here we go. From Jay in the back channel, between all 27 satellites total, they weigh 15,400 kilograms. I'm not quite sure where that.
Yeah, 15,422 if you want to be exact for the mass of the satellites there. So about 34,000 pounds. So you could see there this configuration, the 551. I did see someone ask the question about the fairings, saying, I'm confused by fairing size. Are they the largest? For the Atlas family, yes, they created 2 different variants of payload fairing. So they had the 4-meter fairing and the 5-meter fairing. The 4-meter one, besides being obviously narrower, was a lot stubbier in size. It wasn't as big, and it had a very pointy top rather than the sort of rounded top that you see on your screen here for the 5-meter wide fairing. I mean, they had so many different versions of this rocket, with the 4-meter versus 5-meter, 0, 1, 2, 3, 4, or 5 solid rocket boosters going with each. It's quite a bunch. Let's see here. 98 Central asking, are the SRBs ignited on this Atlas V like the shuttle SRBs were? My understanding is that they are. It's basically, you've got the solid material inside, which is kind of like a peanut butter consistency, and they can actually shape it and mold it so that it will burn at a certain rate. So you can control how strong or weak your solid rocket booster engines are just by the type of propellant that's used and the design that's used inside them. But typically what will happen is when they command the ignition, there is a spark that will light up and go straight down the length of the SRB, igniting things at the base and creating that thrust that we see for those 5 solid rocket boosters. And again, once they are turned on, they will not turn off until they are done. So
actually,
I believe
think
it's similar.
Yeah, I think a great resource to learn how solid rocket motors can behave is actually Joe Bernard or BPS Space on YouTube. He goes through a bunch of this, and he goes through. Am I still roboting?
Yeah, a little bit.
Oh dear, I will try and troubleshoot. Stand by.
But yeah, these are some photos of them rolling it out. By the way, for those who don't know, it's not rolled out horizontally like we're used to seeing with Falcon 9. It's actually rolled out vertically, fully stacked. It goes from the vertical integration facility out to the launch pad at 41, and that is where it is then just attached and ready to go. And D, we now know that there are a couple of different of these VIFs, as they're so called now.
Yes, so there's another one that has been outfitted specifically with Amazon branding, in fact, in support of these sorts of missions and Vulcan, and it makes sense. They're launching both Atlas and Vulcan from the pad. They're trying to launch more and more, and so now they're setting up to be able to increase their launch cadence. ULA has stayed behind SpaceX in terms of launch cadence, while SpaceX has been rapidly accelerating. And so this is one step that will allow them to up their cadence as they work in other ways to potentially up their cadence as well.
Exactly. And they've actually been painting the Amazon logo on the side of VIF A. So it's weird to see that, but the branding is on point, I guess.
Yeah, we've got several of these missions to go on Atlas, and they've only got 10 Atlases left after this one. But then once Vulcan gets its cadence up, because it's been a bit of a slow roll, I'd say, while we saw its first launch previously, like last year, and the second and third, but there has been a large gap in time there that hopefully they will be able to bring down and get launching more regularly.
Yeah, and this was a view that Tori Bruno posted recently. They did a rollout test of one of their new sort of launch structures that you see there that rolls out with it. And this was taken inside that new VIF-A. Well, it's not a new building, but newly branded as VIF-A, I should say. And the important thing with the LEO constellations is that it is rocket agnostic, so it will fly on a whole bunch of different vehicles. So while there may only be 5 total, including this one, flights for Kuiper on Atlas, you still have flights that took off on Falcon 9. They will have flights that take off on Centaur. They also have one coming up early next year that takes place on an Ariane 6. And then, of course, New Glenn also set to launch a bunch of them too. So yeah, you can see there the all of the launches in regards to this constellation, and you see the naming now. They were KA, now they are LA, including, interestingly enough, the European one is LE. I guess it's meant for Europe. I don't know, because it's usually the acronym is the letter for Leo, or K as it was for Kuiper, and then the vehicle is launching on. So A for Atlas, F for Falcon, I believe V for Vulcan, and now for Europe it's LE. So there you go.
Yeah, that's really interesting to see, and it's also really cool to see that the constellation is able to be launched on all these rockets, and that they're sort of launching, like SpaceX launches a competitor set of satellites the same way they did with OneWeb. And so even though they aren't necessarily like direct competitors yet, like Amazon, with some feedback from shareholders, let's say, they even went to SpaceX to launch these satellites, and they're just going around to get whatever launches they can from whatever launch providers there are.
Yeah, again, like I mentioned earlier, they have that deadline that they have to meet, so they'll take whatever they can do to meet that goal. And again, I guess the E must be for Europe, because I was wondering how they were going to do that, given that Atlas and Ariane both start with A. One thing I'm not curious about is the amazing support that we've been getting here. Augmented Coconut, thank you for becoming a PadRat member. Matthew V, upgrading to PadRat member as well. Little B, thank you for becoming a PadRat member. Yol FDK, thank you for gifting 5 Red Team memberships. Very much appreciate that. Anonymous, getting an item from the shop at shop.nestspaceflight.com, saying, thanks for the coverage. I work nights in Fernandina Beach. Never miss a launch. Can go outside for the view. Love being a part of the space program. Keep up the great work. Well, thank you. And enjoy your shirt. Modeled there by Max, I believe, in the corner. So, thank you. And a reminder, if you do get something from the shop, you can leave a message if we're live. And Mr. Fluffy saying, hello, Sawyer, Max, D-Wise. Thank you. Yes, that's it. Oh, and don't bring me down, Goose. I don't want to sing it for copyright strikes, but yeah, it's the song Don't Bring Me Down by ELO. Let's see here. Questions. Here's one from 98 Central. Saying, why is it that modern launch vehicles have no aft fins, like Saturn V and Titan from the good old days? Do you want to take a stab at that one, Max?
First and foremost, Sawyer, how do you have me? So, I'm sorry about that. Going all robot there at first.
You sound much better.
Thank the Lord. Much better. Okay, good. So really, rockets have become a lot more stable over the years, and their own thrust vector control systems have improved dramatically in terms of the onboard avionics. I think the Saturn V was unique in the way it was shaped, of course, with the way the shockwaves were forming over the vehicle, given the dimensions required to hold all 3 stages, and of course the hardware on top. Really, rockets just don't need them anymore, and the rockets that do require an aerodynamic surface for other points in flight, like we see with Falcon 9 and New Glenn, they are not for punching up through the atmosphere. They are coming back down through the atmosphere, and thus changing the way the air behaves over the whole structure. So, essentially, they are just not needed anymore for the actual use. From what we saw, I can't talk. Words are hard tonight. They are not needed anymore based on how much better rockets are constructed and are flying nowadays with the much improved avionics in this modern age. So even Atlas V, as old as it is, by comparison to like Falcon 9 and New Glenn and others, it is just not needed, and it is also a fraction of the size as well.
Yeah, and this is the one thing that I find interesting, especially with Atlas, is that it has a single engine on the bottom of it, the RD-180 engine, which was
Yes.
Russian/Ukrainian made. However, it has two engine bells. It has two nozzles, so it looks like it's two engines, but it's just one RD-180. Correct?
Yes, so there are two engine bells, as you can obviously see on the bottom of the Atlas core stage, and there are two separate combustion chambers as well. But the reason why it is considered one engine is because there's only a singular power head or a single set of turbo pumps feeding them. So that is why it is considered a single engine, and we have seen that as well. The RD-180 is in fact a cut in half version, of the RD-170, which obviously was a 4 engine bell variant of the engine as well. So scaled down from what they were used in the Soviet era, but they are some of the most efficient and high performing Keralox engines ever built. And the fact that we were able to pick them up here in the U.S. and put them to good use was obviously a treat for ULA in particular. Then I believe it was, I can't remember if it was Boeing or Lockheed Martin who inherited them first, or if ULA was already a thing at that point. But either way, the RD-180 is a phenomenal engine.
I believe it used to be Boeing before they merged, so before they became United Launch Alliance, and now they control all of the Atlas and formerly Delta families, and now Vulcan. Which, a reminder, Vulcan is entirely reliant upon American-made engines as opposed to the
Yep.
Russian ones that you see here, with Blue Origin's BE-4s being the power source for Vulcan, in addition to New Glenn.
And what also makes the RD-180 unique in the way that it is, and also why it's so efficient, is that it runs an oxygen-rich preburner, which is unique, especially compared to American engines, because up until the BE-4, I think, every other engine that was produced here in the U.S., whether it be the RS-68, the RS-25, the F-1, Merlin, or in others, they have all run fuel-rich preburners on their power heads, which is not the most efficient, but because of that, it burns cooler, thus being not as harsh on the actual turbo pumps themselves or any other components in the engine coming into contact with the engine's exhaust. With the exhaust in the preburner in the RD-180, running oxygen rich, it is burning at much higher temperatures, and because there is excess oxygen in that actual combustion ratio, that oxygen becomes corrosive and is trying to react with any other material in the engine that it possibly can, and that is why it is so dangerous to run with at times if you don't have the correct alloys in the engine to handle both the temperature and corrosion of the exhaust. If you do, running ox rich means you are burning a lot more of your fuel, thus having a lot more efficiency in the thrust that you are producing. So it's not something that we have gone heavily in on in terms of the engines that we have built here in the U.S., as I already said, up until the BE-4, which is made by Blue Origin, which runs on a mixture of liquid oxygen and liquid methane. I believe it is among the first, if not the first, I think it is actually the first to fly, American engine to run an oxygen-rich preburner as well. And also with it running on methane, it is also unique on that front additionally. So a lot of good stuff coming from the U.S. in recent years, and of course the BE-4 not only used on New Glenn but also powering Vulcan as well, which is ULA's other rocket meant to replace Delta IV and Atlas. So a lot of good stuff here actually, and that is why Atlas is still a very special rocket to fly, because it is one of only 2 rockets I think currently flying here in the U.S. most often. Actually, I guess technically 3. So we have Atlas V, Vulcan, and then, of course, SLS being the last rockets to fly in the U.S. that utilize solid rocket motors in addition to the RD-180 with the Atlas V. So it is a very unique launch visual and, I guess, just experience overall.
Yeah, and this is the exact same launch pad that they will be using for Vulcan, and they do use for Vulcan in addition to Atlas.
That being said, Vulcan has only flown 3 times to this point, and we hope that it flies a lot more very soon.
Absolutely. So as we hit about the 30-minute mark to go until the opening of the window, at this point, Atlas Launch Control is in a hold as planned. So they have built-in holds in their countdown, One of them is about 2 hours, and then this one, which is 44 minutes, I believe, before liftoff. So they will enter that hold, and then they stay there so they can work on some issues or just double check their numbers, whatever that may be. But the L- clock that you see in the top left, now ticking below 30 minutes, is continuing to count. So all is still looking good. And I guess, D, it's a good time to kind of address the L- clock in the room.
Yes, so with most launch providers, we perhaps just see the T minus clock and we know, okay, we're this far away from launch. But things are a bit different with ULA, where they have these built-in holds, and they sort of that is the time that they show publicly. And so we could see like T minus. So we're sitting at T minus 4 minutes, and we've been sitting at T minus 4 minutes. So that's sort of the order of operations that they're following internally. And so that, like you said, they have time to work out these issues. But the L minus time is just the strict time until the anticipated launch, not worrying about the any of the built-in holds or anything like that. So for someone going out there to see a launch, it's the L minus clock that is most helpful to keep an eye on.
Exactly. So that is counting down to the actual time of launch. It doesn't take into account the planned holds. So that's why it says L- up in the corner. And it's worth noting that this countdown started hours and hours ago. And unlike Falcon 9, where we're used to seeing them start fueling at about this point in the countdown, fueling has been well underway at this point on Atlas V. In fact, it rolls out to the launch pad with its rocket propellant 1, the kerosene, from the VIP, basically, from the vehicle integration building that they have there. Since that's kept basically at ambient temperature, then once they get out there, that's when they start loading the liquid oxygen both onto the first stage as well as the second stage. Plus, the second stage also does not burn on RP1, it actually uses hydrogen. So they also have to load that into stage 2 for their Centaur upper engine.
And
So
that's also
far.
why they are not limited to a load and go procedure, and that is why Atlas is able to hold. Obviously, again, the RP1 being just at ambient temperature, they aren't working with any constraints with it being super chilled and its density increasing or I should say decreasing with the temperature coming up. But with the locks, they have the ability to top off as they have to, both on Centaur and on the core stage as well, and same with the hydrogen also on the Centaur upper stage. So it's a lot more chill. Pun not intended, I promise. But it's a lot more laid back in comparison to the load and go procedures that we see with Falcon, and it also gives teams a lot more time to analyze how the rocket is behaving with its cryogenic propellants. So it's a lot more laid back comparison to watching either Falcon 9 or Falcon Heavy, or even Starship at this point, with how fast Starship currently loads and how fast it is going to load in the future, especially at Pad 2.
That is very true, yeah. So, kind of doing it the old school way, but hey, it works. And of course, while the concern is also about the features on the rocket, one of the main things we have to be wary of, as we saw last night, was that last night? This morning, whatever it was, is of the weather. And I believe we have a latest update from ULA, and you can see it, that weather is observed go for liftoff from the official update. So weather is go. You could see originally it was a 95% chance of favorable weather, the only concern being the cumulus cloud rule. But officially, they do their final weather briefing at that L- 30-minute mark, and it is go. So now the vehicle just has to do what it needs to do. Also, at this point, there it is, they are uploading what's known as the adjust file, which is my favorite file name of all time if you've seen me on Atlas streams. It is the automatic determination and dissemination of just updated steering terms. So, what they do is, after they do that weather briefing, they get the final winds, winds aloft, winds on the ground, all of that, and they use that to adjust their trajectory just a little bit to deal with winds, to deal with any potential weather, and that goes into the inertial navigation control assembly. You see there the Inca. So that is what that does. They wait till they get that final weather go, and then they adjust the file as a fuel fill sequence is beginning. So That means that the tanks are pretty much been topping off at this point, and that RP1 at room temperature is now going to start to be released into the main engine in preparation for liftoff. I guess, Max, it's not really an engine chill, but it's kind of prepping the engines anyway for launch by doing that, right?
I mean, it is in a way because you still have to chill the LOX side of the engine because you don't want to be flowing cryogenic liquid oxygen into any sort of material into it without it being at the proper temperature. Good lord, for it risking for the risk of it flashing suddenly into a gas and rapidly expanding and causing a whole bunch of issues with the hardware on the vehicle and also potentially on the ground as well, depending on what else is happening. But yeah, you still have to chill at least half of the engine. Obviously, with the RP1, you don't have to, I believe, because it is still at the ambient temperature. But that also makes it unique in that one side of the pumps is at a super cold temperature and the other is not, which makes for some very interesting engineering problems to solve in terms of tolerance, because on one side you have it basically as it was before, and then on the other it is wanting to contract because the LOX is so cold. That is also why the RD-180 is a very unique engine to see work in action. So lots happening here, but chill down is still necessary, and especially on the RL-10C engine on Centaur. Because obviously that is running hydrogen and oxygen as its fuel, and those, of course, are also super cold and cryogenic, which also require thermal conditioning. But of course, they have a lot more time to do so on Atlas V because they are not as time constrained as other launch vehicles here in Florida.
Right. Although the window for this mission is on the shorter side. The window opens at 3:28 a.m. Eastern Time, which is 23 minutes and 23 seconds from now, but only goes until about 3:57 a.m. So essentially a 59-minute window, or sorry, a 39-minute window that they're working with. Or is it 29 minutes? Math. Yeah, 29-minute window. Thank you.
Math is hard. Math and talking are hard at 3 a.m., folks.
I was going to say, especially
Ask
this
me how I
afternoon.
know.
But anyway, so it is a 29-minute launch window. So hopefully they don't need it, but if they do, they have that little bit of wiggle room.
But at the moment, I think it has to be worth saying that obviously we just covered the weather and all is looking great on the weather front. But the team is currently working no issues on the vehicle or on the ground. So at least at the current time. So all is looking good.
That's what we like to hear, and that's what we like to see. Also, like to see the amazing support coming in. Bideford, love saying your name, Bideford. Thank you so much with a $25 super chat saying happy another launch day. Yes, it is. I guess because a lot of people were talking about birthdays in chat. Happy another launch day to all, including our producer Jay Keegan, who I apparently forgot to mention earlier. And if I did, I apologize. But yeah, Jay's the one pushing the buttons, pulling the levers today.
Never forget the producer.
Yeah, about that.
That's never happened before, ever.
So about that producer remembering, I think it may have delayed a bit.
Oh my god. Anyway. So for those who don't know, again, this is the Atlas V 551 launching 27 satellites for Amazon's internet constellation. And I don't know if we know the exact reasoning behind it, but I mean, Max, we had the rebrand between these last launches of internet satellites for Amazon.
Yeah, I don't know what conversations were had internally about the reasoning behind the name change or whether or not this was in the works for a while and just wasn't implemented. I'm honestly not sure. I don't believe that there was a press release as to why, but there obviously was just for the name change in general. But I think the common consensus between us here and also just talking amongst colleagues is that the Leo name might not be as well received. But obviously, it is their payload and their company. They are allowed to name it as they see fit. Although I do have to say the fairing art does look mighty lovely. So Amazon Leo, go ahead, D.
They did actually, in the press release, give some context as the early team began operating under the name Project Kuiper, based on the inspiration of the Kuiper Belt. and Leo is meant to just be a more simple, like, tie-in to the orbit that they're going to, and just more relevant to the average people. So they didn't go into an incredible amount of detail, but that was their sort of public explanation for the rebrand.
And I guess it kind of has that double meaning to it. Besides Amazon Leo, it is launching into low Earth orbit, which we call Leo. You also have the constellation Leo up there as well, and this will be an internet satellite constellation. So I can see some of the clever wordplay that they tried with the naming, at least. We are now less than 20 minutes away from the opening of the window, hopefully when this mission will take off. So far, it appears that there are not any issues, that they have been working over in Mission Control at the Advanced Spacecraft Operations Center, or ASOC, which is located on Cape Canaveral Space Force Station. They also have, I believe, teams out in Colorado that are working on this as well. And you can see a look into that as well, to the ASOC, as well as the other ULA teams, the ones that I believe are in Colorado. And also getting word that the upper level winds have been verified go for launch.
Excellent.
So Mother Nature is playing nice. One thing we were talking about earlier is, obviously there's a bit of competition, because when you think of internet satellites, the first thing you think of is Starlink. But how does this really compare to Starlink? And in terms of launches, like, what altitude are we seeing this one at max versus what we see for SpaceX?
So Kuiper and Leo have been targeting around the 450 kilometer altitude-ish for their constellation, at least at this point in this current shell. And we go back to Starlink. I can't remember. Good Lord. I know I'm a terrible host. I'm a terrible host. I want to say Starlink is around 500 kilometers or 600 kilometers in No, I'm sorry. 400. Oh gosh. Somebody help. I'm blanking. Oh gosh, but at least Kuiper and Leo target about 450 kilometers in altitude. So that is why they are going there. Alex is typing the back channel. Maybe he'll save us. Alex is still typing. Alex is still typing.
It's an Alex like to answer my message as well.
Oh, go D.
There are a number of differences. We've seen the Starlinks go into various orbital shells. So the actual orbit is the same as some Starlink shells in the 500 to 600 kilometer range, because they deploy at a lower altitude. Thank you, Alex. It's also worth noting the pure size of the constellation. Amazon Leo is going with a bit slower of a ramp up so far, and is starting with far, far less satellites. Of course, the early versions of Starlink were launching with 60 satellites on a single Falcon 9. And after a lot of those, they moved to launches with the V2 minis, now more V2 branded, in the low 20s. And they've been able to optimize that up to close to 30. And so, I mean, there are a number of differences. Alex is also noting that direct-to-cell operates at lower altitudes of 350 to 400 kilometers to help those satellites be able to communicate directly with phones that don't have the benefit of those phased array antennas built into the phones themselves. So, it'll be really interesting to see once the constellation is operating for more average consumers, how they truly compare.
Yeah, that is true. I mean, again, they still have a lot more satellites to launch at this point. If memory serves me right, especially because I have the number open here, so far it is. Where's the number? Again, we're so great at this tonight. They will have 180 production satellites in orbit after this flight, which compared to the 8,000 or 9,000 that we've seen with Starlink, they're definitely on a slower pace, but they still are working on their network. And one thing they're also not working on the moment is that fuel fill that we were talking about with the engine. The fuel fill sequence has been completed. exactly as planned. So to use Alex's pun from the back channel here, you could say that the RD-180 is now Amazon Primed.
Oh, geez.
I wish I'd have thought of that one. That was good, Alex, because it's also known as priming the engine. So yeah, blame Alex for that one, but it was really good. I had to mention it.
The number of puns will be even more so once we have LEO launches on New Glenn. Then like I'm sure the puns and references will be extreme. I am scared for that day, to be totally honest, Sawyer.
Yeah. Although at this point, I do like the fact that with the new name, it's LA-04 for the mission. That is meant for Leo for the constellation, Atlas for the rocket it's launching on, 04 being the fourth operational flight for these.
So does that mean for like New Glenn it'll be LNG/01 and 02 and so on and so forth, and for Vulcan, LV? I mean, LV sounds cooler, but LNG is literally also an acronym for liquid natural gas.
I think that's
I'm
what you were
curious to
hinting at.
see.
That was exactly what I was gonna say too, and it'd be so perfect if they go for LNG for the launches on New Glenn.
Which is perfect because that is the fuel that New Glenn's first stage utilizes, which is liquid natural gas or methane, depending on how you want to phrase it, with all 7 of its BE4s as well. So a weird coincidence there.
Indeed.
Alex is saying he thinks it's just gonna be LN number, and I think that's sad.
So Leo New /XX, that sounds kind of weird.
Yeah, I mean, it kind of does, especially when you would have the double acronyms there of what?
Check the
Alex
back
said
channel.
liquid nitrogen.
Yeah, liquid nitrogen, LN.
And-
Well,
Yeah.
wouldn't that be lithium and nitrogen? But anyway, yeah. Regardless, it's going to be interesting when we get to that naming nomenclature. But for now, we are getting to within 13 minutes of launch of Atlas V here. They are currently doing polling at the technical team that they have located in Denver, Colorado. So they're the ones that do evaluations of all the rocket data and systems as they come in throughout the countdown. And once that is done, they will relay that information to the launch director, who is located, as mentioned, at the Cape Canaveral Space Force Station, just a couple miles away from the pad in the ASOC. And they will include that when they do their go, no-go poll, which, a reminder, is something that, unlike SpaceX, they actually do out loud. So we will hear the go, no-go poll when the time comes. And that's usually at about the L-7 minute mark. So about 5 minutes away from that. Here's one from ResistoJet saying, how does the propellant loading sequence on Atlas V differ from Falcon 9? And can it be restarted unlike Falcon 9? D, do you want to try that one, or do you want Max to take it?
Max can take that one.
Sure. So, unlike Falcon 9, which is where SpaceX resorts to a load and go procedure to preserve as much propellant density, because both RP1 and LOX are super chilled on Falcon 9 and Falcon Heavy, they are able to load Atlas 5 hours in advance for both LOX and hydrogen for the first stage LOX, and also, of course, hydrogen and LOX on the Centaur upper stage. But they are words. Good lord. They are also able to load room temperature or ambient temperature RP1 into the Atlas V core stage while it's still inside the VIF, of course, because it's at ambient temperatures and not super chilled. So it's not a super time-sensitive matter in terms of it losing density, or I should say gaining density. No, losing the density, good lord, as time goes on and it warms up. That is what makes Atlas and Falcon all that much more different, just in terms of their fueling procedures. Atlas V also, because of that, has the ability to hold, with both being able to hold the RP1 load as it is for an advanced period of time, but also because they also have the ability to replenish and top off the hydrogen and LOX on the rocket as well. So that is why, and of course with Falcon, once you go into prop load at T-minus 38 minutes, which is when that poll is conducted, either go or no go, you are then committed to that T0 if you are go, and go into prop load at that point. So these rockets could not be more different if they tried.
Yeah, and the topping off continues pretty much all the way up until a couple of minutes before launch. So that will kind of just be trickling in and keeping them topped off for anything that would otherwise sublimate or evaporate away.
Correct.
And the latest that we're hearing now also is that the Kuiper satellites have been successfully switched to what is known as flight mode. So that means that the LEO hardware atop Atlas is now set in its launch configuration and ready for liftoff, as we are now 10 minutes away. This is getting really exciting. By the way, the person I saw in chat saying they're based in Centennial and not Denver, I'm going off of what they posted on their official launch blog. They call it Denver. So I don't know if it's a different team they have in Denver versus Centennial. I know they have a lot of their base and everything set up in Centennial, Colorado.
Roger.
Ooh.
OSM, place SRB ignition SNA switch in the enable position.
SRB ignition enabled.
Box 2, verify CISA purge flowing GN2 to the CISA.
Verified.
OSM, verify the FCO, ROC, and OSM fire switches are in the Pro-C position.
Ready to proceed.
RLM, verify redline monitor and vent table are in the correct configuration for terminal count. Verified. RC, verify solar radiation.
As we get closer to the opening of our launch window, let's have a look at the weather forecast our launch team just...
Well, as you can see there in the corner, as they were just talking about, weather remains extremely favorable at about the 30-minute to go mark. L-minus 30 minutes, that is when the weather team gave the final go for weather. Said all will be perfect for launch, essentially. All of the upper-level winds have also been deemed to be within limits. So weather is cooperating for tonight's launch of the Atlas 551. Which,
Good news.
Yes. Which, by the way, they do all have nicknames, in case you're unaware. This one, the 551, is known as the Bruiser. 541 was known as the Beast. The 531 was the Thunderer. You had the 421 Sprinter, the 411 Slider, and the 401 Slick Atlas as some of the nicknames.
Which is, I have to mention every single time that this conversation comes up, there's literal video record of Tori Bruno calling the 551 the Beast, and then implying the 541 was the Bruiser. And since then, they have been switched. I don't know why, because the Beast actually sounds best for the most powerful variant of the Atlas V. I don't know. It's a weird quirk that always gets me a little irked, I guess, every single time it comes up, but alas.
But either way, it still means that is the 5-meter fairing for this variant with 5 solid rocket boosters and 1 upper stage Centaur engine. That is why it is the 551. And we are now 7.5 minutes away from the opening of the window, which is their currently scheduled T0. In just a couple of seconds, we should hopefully be hearing the launch team conduct their readiness poll. Scott Barney is the launch conductor who will be operating that poll. So we'll go ahead and listen in while we send the field team off to cover the launch. Max will check in with you guys after.
Sounds good to me, everybody. Thank you very much, and we will see y'all on the other side.
All right, there's the L-minus 7-minute mark. Let's listen in.
Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur system, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
HAS gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Op support.
Go.
COM. Go. Umbilicals.
Go.
Environmental control system.
Go.
Redline monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range and weather.
Go.
Launch director.
LC, this is LD. You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 0828000.
Polling is complete and the team is go.
And there we go. That is the go for launch. You heard there, again, the voice of launch conductor Scott Barney, and that final go from launch director Don Malin. They are going to proceed with tonight's countdown, which is exactly what we are hoping for. So we should start seeing all of those topping off of propellants wrap up. And as we do so, they will get into the terminal count. So once we get into the terminal count, that means that the onboard computers will be in control of all of the flight checkouts and everything leading up to launch. At that point, of course, they will still be monitoring it from the ground, both at the Cape Canaveral Space Force Station, at the ASOC, the Advanced Spacecraft Operations Center, as well as out at their facilities in Colorado. Coming up on about 5 minutes to go, about a minute after that is when they will restart the T-minus clock. So right now the T-minus clock is in a hold, and that is the difference between the T-minus and L-minus. The L-minus clock does not stop. So that is why it's continuing to count, but you will hear them likely mention coming out of a hold. That is normal. That is exactly as planned, so it is nothing to worry about there. And you can also see some of that venting still coming off. Again, the chilled propellants on board, they are quite cold. Maybe not SpaceX level cold, but they're definitely cold out there. Stage 1 loaded up with RP1, Rocket Propellant 1, before it even rolls out. And then once it's at the pad, a couple hours before launch, that's when they start the propellant load. So stage 1 uses the RP1 and liquid oxygen. Stage 2, with the Centaur upper stage, uses hydrogen and oxygen. And then the satellites themselves, to get into their final orbit, have thrusters known as Hall effect thrusters that use krypton to help propel them to where they need to be. And we should be hearing that they have resumed the count any second. And there we go. The countdown is continuing. So the T-minus 4-minute hold has been released right on time. The T-minus and L-minus clocks are now synchronized, so we will change our clock there as well. About 3.5 minutes to go in the final phases of the count for the 4th launch of Amazon's LEO internet satellites aboard Atlas. 3.5 minutes. Again, as we get down into the count, once we get really low, that is when we'll start to see things kick into action. The RD-180 engine at the base kicks in at about 3 seconds before launch. At that point, it then ramps up the thrust-to-weight ratio, which will allow it to get off of the pad. That will happen about 1 second before launch, or 1 second after launch, and then at that point, it will do a sort of turn maneuver, a yaw, pitch, and roll maneuver. And it will send it on its trajectory, which for those who don't know, tonight this is a northeasterly launch. So, if you are anywhere along the eastern seaboard of the United States, up towards the eastern portions of Canada there, definitely go outside and take a look. And if you see anything, tag us on social media. We are on Facebook, Instagram, Threads, TikTok, Blue Sky, all of those. Send them to us. I'd love to see if you get any shots of it. 2.5 minutes to go at this point. We should be getting close to everything finishing topping off and getting everything set into those flight configurations. Again, at this point, with that clock resumed, they are in the terminal part of the count. So the onboard computers are monitoring everything right now. We are now at 2 minutes to go until liftoff. So far, everything looking good. Again, this will be delivering 27 of these Amazon LEO satellites into orbit. The start command has been issued for the launch sequence. That does all the verifications of systems for the rest of the countdown, controls the detachment of the umbilicals, and will eventually release the rocket when it comes time. The first stage propellants have now stepped up to their pressure levels for flight. Meanwhile, the Atlas and Centaur stages both are now on their own internal power, no longer relying on the ground power. And T-minus 80 seconds, the ordnance controller and the vehicle safety system have been armed. So if anything were to go wrong, they have the ability to activate it now at this point. We should also be coming up on first stage, liquid oxygen, liquid hydrogen propellant topping to finish off on the Centaur upper stage,
T-minus 1
securing
minute.
the tank.
Rock, report range status.
Range green.
There we go. 1 minute to go. Of course, at T-minus 25 seconds is when we will hear the final go, no-go poll with the status check. So we will hopefully hear that momentarily. So far, everything proceeding as planned. Right now, the firing chain is armed as well for the solid rocket boosters. They are ready for ignition. as is
28.
the RD-180 engine.
Verify ECS reduced for launch.
Verified.
Status check.
Go Atlas.
Go Centaur.
Go Amazon Leo.
There we go. There's the go. 15 seconds.
10,
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1, and liftoff of the United Launch Alliance Atlas V rocket, carrying 27 satellites for Amazon Leo. Spacecraft delivering fast, reliable internet to customers around the world.
Control closed loop control. Engaging first throttle segment as expected. And we've completed our pitch program. Hydraulics continue to look good. Successfully completed roll program. Booster engine continues to operate as expected. Mach 1, Atlas V is now supersonic. Engine continues to operate
We're
as
here in
expected.
Sarah Bailey, Glasgow, providing launch vehicle ascent data.
Vehicle is now 6 miles in altitude, 2 miles downrange. Atlas continues to move down the center of the range track. Now passing
Vehicle should
1
be
minute
passing
into
through
flight.
max Q. Pass maximum aerodynamic forces on the vehicle. Next up will be the
Body
jettison
rates
of those
continue to look good.
five solid rocket boosters.
Engine
That will
operating as
happen about
expected.
1:46 into flight. So about 30 seconds from now.
Throttling down, engine continues to burn normally. Atlas is now moving at 2,800 miles an hour and is 12 miles downrange.
You also hear some of the car
Vehicle
alarms
is
from
now
how
1/2
loud
of
that
its
is.
liftoff weight. Max Q, passing through maximum dynamic pressure. And we have good indication of SRB burnout.
All right, there we go.
Throttling
The
up as
SRBs have now
expected.
burned out. And it should be coming up on the separation. And there they go. As you can see by the ice falling off, in addition to those solid rocket boosters,
And we have good
is in a
indication of
pattern.
separation of all 5 SRBs. Engine continues to burn normally.
You see that pattern release. There we go. That is not
We
parts of
just
the
heard
rocket breaking up.
confirmation of
Those
solid
dots are
rocket
all of the
booster
SRBs.
jettison. These additional motors augmented the thrust.
So that is the solid rocket boosters falling away. These are not reusable, by the way. So those will end up splashing down in the ocean if anything survives of them. And meanwhile, same with the rest of Atlas V, that will
Body rates are
continue
smooth.
and will not be reused.
2
So for
minutes
Atlas
to
V, now
nominal
on
BECO.
closed loop guidance. Now more than 50 miles in altitude, 65
Vehicle
miles
continues to move down the
downrange.
center of the range track.
Right on target. So again, that stage separation
Holding acceleration
should be
at
coming up.
2.5 Gs in preparation for payload fairing jettison.
There we go. The payload fairing jettison should happen in about
Centaur reaction
25-ish
control system
seconds.
pressurizing to flight levels as expected. Vehicle is
They
past
don't
the Kármán
typically
line,
show
we've
it, though.
Exited Earth's atmosphere.
There's the Kármán
Atlas
line.
is now 1/4 of its liftoff weight. Engine continues to burn as expected.
Now we should get fairing separation.
And we have good indication of payload fairing jettison.
Wow, you could even see it in that
and
shot.
CFLR deck jettison. Throttling back up as expected.
Flight commentator Sarah Bailey, Glasgow, just called out confirmation of payload fairing jettison. The composite.
There we go. And again, those, unlike SpaceX's, are not reused either. Those will splash down into the water, and that is the end of the fairing halves. Stage 1 is still continuing to operate normally at this point, and will continue to do so for just a little bit longer. This stage will burn until about 4 minutes and 22 seconds into flight. So approximately 30-ish seconds from now is when we will see BECO, which is booster engine cutoff. That is when the RD-180 engine on that stage will shut down. That will be followed a couple seconds later by the booster Centaur separation, and then we will have the Centaur main engine start 1, MES1 as it's known, and that is when that RL-10C engine will perform its part of the job in firing for about 13-ish seconds or so, or 13-ish minutes, excuse me, or so. So standing by for BECO. There it is. That's booster engine cutoff.
And good indication of Centaur separation.
Beautiful view.
Restart on fuel and locks. Good staging. Ignition and full thrust. Railton is running nominally.
There we go. You don't see as much of a flame as you typically do with Falcon 9, as because this is not using kerosene. This is using liquid hydrogen and liquid oxygen to help propel Stage 2 and those 27 Amazon LEO satellites. This burn will continue until about 17 and a half minutes into flight. Unbelievable. Do we have any of the field team back to talk about that? Max, how was that?
I was just going to type into... Oh, can we clear field audio, Jay?
Nothing like a little echo, that's all.
There we go. Yeah, sorry about the echo, y'all. Tracking a 551 Atlas is a tricky thing because it is very, very fast, as you probably saw on your screens. I believe it is the quickest accelerating launch vehicle currently on the East Coast, minus a Minotaur. Haven't seen one of those fly in a very long time, though, but I believe we still have it.
We do.
On feet there. Wow.
Can absolutely still see it.
Which is kind of amazing because the exhaust from Centaur doesn't burn anywhere near as bright, if not translucent, compared to its Carolox counterpart in Falcon 9's upper stage. I'm trying to look for it with my naked eye. I cannot see it, but obviously D's camera still does, so that's fantastic.
That's amazing. So far, everything continuing to look good. Of course, they do not show any onboard views of the Kuiper satellites, so this is what we have right now. Rocket is now streaking by New York City if you're outside to pop out and take a look. Now 200 miles in altitude. The RL-10C is continuing to operate as expected. This will place the vehicle into a near circular 450-kilometer orbit to start things off when the burn is done. It's about 280 miles, inclined 51.9 degrees. It will then use its own Hall effect thrusters at the top to be able to propel itself into its final orbit of around 630 kilometers in altitude, and they will do that over a period of time rather than right away to it. But right now, everything going well as we pass the 7-minute mark, 250 miles in altitude, now passing by Boston if you're outside. It's continuing that northeasterly trajectory. The data is now, instead of coming from ground stations, coming from TDRS, which is NASA's Tracking Data Relay Satellite System. So instead of using ground systems to send its data back, they are now using geosynchronous satellites to do it. And I think we finally just lost our visual of Centaur after 7.5 minutes of flight. We're still continuing to get updates on data, but we do not have any visuals from Atlas itself, which is just part of the vehicle.
There was a cloud in the sky that blocked it there. It was so faint at the end, and as it got lower and lower on the horizon, there's just a distant cloud that blocked it, and the likelihood of reacquiring that is very, very low.
I'm amazed you had it as long as you did.
Same.
That is faint.
It was very faint, but honestly, the conditions were just really lucky to make it just barely still visible.
Absolutely. I saw a lot of people in chat saying that they were able to see it where they are. I can't wait to see some photos and video.
Yes, please post it and tag us. We want to see it.
Speed is now already at 12,800 miles per hour as we pass 8.5 minutes into flight. Centaur is continuing on its single burn to bring those Amazon LEO satellites into their initial orbit. Again, that relies on liquid hydrogen and liquid oxygen. So everything looking good so far from all the data coming down from TDRS and from the rocket. And of course, we will have replays for you coming up very shortly from all of our views. It is a very fast vehicle. So it might need the slow-mo replay to be able to see it later, but Atlas jumps off the pad. And I think people don't realize that, especially when you compare it to something like a Falcon 9.
100%. Yeah, it always catches me off guard, and it's not like we have a ton of practice with it as well, because we don't see it fly nearly as often as we see Falcon 9 do, as just for a comparison and muscle memory. My track was a little bit rough, I do have to say, once Jay pulls it up on the replay. So not the most proud of it, but we still saw it. But there is one cloud above our heads that was very annoying and blocked the view for a little bit, which made acquiring it once it came out of the cloud a bit tricky. But we still saw it. It was still beautiful, and I almost had Kuiper. Leo is getting to where it needs to go, and with it riding aboard Centaur, the odds of it getting there are very high.
That is very true. So we're now over 10 minutes into flight. So far, all of the data that they are receiving at the launch control areas and their mission control looks to be good. And this burn will continue, as we mentioned earlier, till a little after T plus 17 minutes. So there's still plenty of time left in this burn. In fact, it should burn out at around T plus 17 minutes and 32 seconds. Of course, that is their projected times. That will change based off of the actual in-flight rocket telemetry. The computers will make those adjustments so that it hits that intended orbit. Atlas V now continuing its climb at over 13,000 miles per hour, now over the Atlantic already. Engine is operating as expected and nearing the end of powered flight in about 6-ish minutes from now. Now at 290 miles in altitude east of Newfoundland. So far, body rates look normal. Upper stage performance is normal. So far, so good. I do miss being able to see the satellites and the deploy, I will say that, but Amazon has done that for all of their launches so far on all of the different vehicles, right?
Yeah, agreed on that front, but we also have the same issue whenever they launch a payload for the National Reconnaissance Office or any other payload that is classified for either the Air Force, the Space Force, anything that is with, I guess, the U.S. government. So a bit of a bummer, but not something we are entirely unused to seeing, especially with Atlas V and Vulcan and Centaur nowadays.
Yeah, that is true. And Vulcan, another one that jumps off the pad like this.
I mean, depending on the configuration, especially with the most recent launch they had was the VC4, the Vulcan Centaur 4, with 4 solid rocket motors on it. I believe the VC4 at that point, and still is, the most powerful launch vehicle to fly from Space Launch Complex 41, even topping out an Atlas V 551. But if you compare that to the VC2, which flew the first couple of flights of Vulcan, actually two of the 3 flights of Vulcan so far have been VC2s. It wasn't that fast off the pad, and that is because those solid rocket motors are incredibly powerful and have an amazing thrust-to-weight ratio and boost Vulcan's performance immensely, even just going from 2 to 4 solids. I cannot wait to see what a VC6 looks like, especially with Kuiper and other. I did it again, Leo and other heavy payloads that require a 6 solid variant of Vulcan. So that will be a definite camera killer at 41 if your cameras are in the wrong spot.
And I believe we do have cameras out at the launch pad too for this one. So when we do get those shots, keep an eye out on the socials for them. I'm sure our team will be sharing them.
Yeah, to be honest with you, Sawyer, I don't have a ton of hope in those turning out simply because it is 3 o'clock in the morning. There is a lot of dew on a lot of objects around here, and I'm sure the conditions at 41 are very similar. And at this point, anyone who is using manual hand warmers or just, I guess, ordinary hand warmers to keep lenses in gear warm enough and above dew point, cough, which was also me, are obviously well expired at this point, and everything is likely dewed over. At least that's my expectation. If my remotes actually got anything usable, it'll be a bonus. I have 2 more cameras over here at the press site shooting just in case, so I have something and I'm not empty-handed. But we will have to wait and see. We will be going out to pick those up in just a few hours.
Yep. The fun never stops. And meanwhile, so far, Centaur has not stopped either. With under 4 minutes left on this engine burn, is now traveling more than 15,000 miles per hour. And so far, everything continues to look good. And Max, you guys aren't done for the day yet. There's still more launches today. And I mean, besides the fact this mission is still ongoing, Atlas V is still burning. We just don't see it. All we have is the information. There's
Today?
another launch.
Are you referring to the Starlink in the morning?
Yes, I am.
That was pushed
That
to Wednesday,
should
Sawyer.
be-
Oh, Wednesday.
Yeah.
Okay.
Yeah, thankfully. That would have made for a very long night for all of us here, especially when the original schedule for Monday was, I believe it was 3 within, I think, 12 or 14 hours of each other, which would have been fun for all of us. But as cool as that would have been, I know, especially with them being at just not great times of the day, the rest from both D and I is greatly appreciated just from among ourselves, because we don't have a ton of it nowadays, especially with how often stuff is happening.
That is true. I should have just texted next space flight. As we pass the 15.5-minute mark into flight, Atlas now over the central North Atlantic. Centaur systems remain in good shape, continuing to power into orbit. So far, it still continues to be good. So it's less than 2 minutes now in powered flight. So for this particular burn. And once that is done at the 17.5-minute mark, it will begin separating those payloads, those satellites, at about the T plus 20-minute mark, all the way until the T plus 35-minute mark. So it is a 15-minute deploy sequence for those 27 satellites. And now everything looks good. The Amazon LEO payloads, by the way, are the heaviest ever carried by Atlas V. And so far, it's pushed them like there was absolutely nothing to it. And the second stage will have another burn, by the way. It will have MES-2, Main Engine Start 2, which is a 11-second burn that is used to deorbit the upper stage. And here are some of the replays. This from Rusty's at the port, where they kindly let us place a couple of our cameras that you can see on Space Coast Live 24/7.
And just like the Starlink yesterday, straight into the clouds, first thing.
At least this one popped back out of the clouds, though.
That's also true. And it also got there a lot faster than Falcon 9 did as well.
Oh, yeah. Beautiful views. At this point, Atlas is now orbital, just waiting for the official confirmation that it is in the desired deployment orbit. We should get that in about 20 seconds. Beautiful replays as always, too. We've got a lot of cameras.
But wait, there's more.
It's from one of ours at the press site. And we have confirmation of MECO. So
Excellent.
The main engine has cut off. That is the RL-10 engine on the Centaur upper stage. Atlas V achieving low Earth orbit for LEO. Look at that punching through the clouds there. It looked like lightning, but it's not.
It's also unique to see a rocket leave a smoke trail as prominent as Atlas and Vulcan do, because, of course, every other rocket currently flying here in the U.S. either uses RP-1 or methane, which does not really leave a thick trail behind it. But, of course, solid rocket motors do when they burn. And I believe this is a robot. Yeah, robot. This is one of our other robot cameras here over at the press site as well. And look at how fast it leaps off the pad there. Holy cow.
Yeah, as quick as it's there, it's gone. And
literally, yeah.
And it's so much dirtier. Yes, the residue left from those solid rocket boosters, you see it in that cloud. It also leads to some interesting things for when you go to pick up cameras out at said launch pad that were there during liftoff, as there is residue that is left by those SRBs. And yeah, don't touch it unless you have gloves or something on. Not that I'm speaking from experience or anything, but it may or may not make your hands go all tingly.
It can, and it is also wise to keep your fingers or whatever extremities away from either your eyes, your nozzles, and your mouth, especially because that can lead to other problems. It is a really nasty substance that can coat your cameras if they are in just the wrong spot. Although tonight didn't look too bad, and I'm really curious to see how everything held up, because if they had launched yesterday, the wind was blowing directly south, and that is where most of our cameras were located, and they would have gotten just absolutely smoked. But I'm not quite sure how they fared this time, but we'll have to wait and see.
We will definitely wait and see. This one of DY's cameras as well out there. Getting that wide view. I love the reflection in the water. Which I don't know if I asked, how was the sound tonight, by the way?
Atlas V is not usually a loud rocket by comparison to Falcon, especially. Although that being said, it's not quiet, and I'm not sure if the mic picked it up as well. But there was some brief VAB squeal as well, as we often hear from missions at like 40. Just because the sound coming from the rocket is traveling at just the right angle towards the VAB, and having the panels on the exterior of it reverb and shake at such that there is a noise coming off of it, a squeal, I guess you could say, but very brief. But the volume from Atlas V usually isn't too great because the exhaust from the RD-180 is not all that violent in the way that they that the plumes interact with each other, and I want to say a majority of the sound that we hear in the crackle comes from the rough burning SRBs or SRMs, I guess, as ULA calls them on the Atlas V and Vulcan. So it's great. It sounds amazing, but it's just not as loud as perhaps we have become used to nowadays.
Speaking of the SRBs, with them being so bright, I'm really glad I did this ultra wide shot because as Atlas broke through the clouds and then got above it, you were able to see almost the shape of the upper portion of the clouds through the shadows that they cast on the other clouds. I, you know, we like the clear skies in order to have the clean shots of the rocket and easy tracking, but sometimes the clouds can lead to some incredibly beautiful pictures and videos.
Absolutely. As we get this cool behind the scenes view of you operating the tracking camera. Again, like I was saying with Max, it is so difficult when you have a rocket that fast to begin with. 'Cause you kind of
It can
start to
be
get into you start to get into a groove with Falcon 9. You kind of know the pace that it goes up at. It's a little different with Atlas.
yeah, you sort of have to be used to it, but regardless, like you always have to be ready for the different speeds of the rockets, and it's not like it's a whip track or anything like that. They're not crazy speeds that you're tracking at still. It's just not letting yourself get too much into the muscle memory of things.
Yeah. That is true.
Yeah, I I had the track almost to the horizon there. So Jay in the back channel saying, "I'm gonna skip ahead."
Yeah,
Yeah, we
just
don't
a
need
little,
to
huh?
watch all 7 minutes of it.
Yeah. And it's cool to see the art being made, then the art after it's done. So I believe we'll also have the actual track of that, which beautiful night launch tonight. And with that, we are also at the point in terms of Atlas remaining. We're getting low. There are now only 10 Atlas V rockets remaining. Let's watch the replay of the liftoff from D's camera.
This one should be Max's track.
Or sorry, Max's camera, excuse me.
Some squeal there from the VAB.
It is a very different rumble with Atlas. And by the way, the sparks that you see, totally normal. Obviously, it made the payload made it to orbit. A lot of times you'll see that with the ice. Sometimes there are some metallic particles that will flick off because solid rocket boosters are quite powerful, and you'll see them kind of sparking in the exhaust. But obviously, not an issue. This is not the type of observation like we saw with the second flight of Vulcan. It's weird to say that, but that is normal as the separation happens.
Yeah, so you say that, but I still, because of that one flight in particular, whenever I do see any bit of like larger solid material coming from the solids, I'm always keeping my eyes peeled to see if anything else comes out, because it is natural. Because of the way solid rocket motors or boosters burn, not all of the exhaust remnants are just super hot flaming gas. There are more solid bits of propellant coming out as well, which are the sparky bits that we see coming out of them, and obviously they burn a lot rougher as well, and nowhere near as linearly as liquid fueled engines as well. So, it is normal, but because of Vulcan Flight 2, just from my experience, I'm always looking out for anything that looks a bit more sparky than normal, or anything else that looks like it could be abnormal. So, a bit of not PTSD, but I guess just training for SRBs.
Yeah, I got a little worried at first too, but considering we saw it on the previous Night Atlas launch as well, and this is only the second Night Atlas launch since about 3 years ago, so it's one of those where you don't really see it as much in the daylight, I guess. But then coming up right there as they're chilling down that upper engine, and then the payload fairing separation as well. Absolute. There it is. That's the payload fairing jettison. You can see that big poof out sideways on each side. Love it. Well, let me also take a moment here and thank the Uber Kitten for becoming a Capcom member. Reminder, Capcom at above, getting that extra access to the NSF Discord. Pre and post show are in there for the Flame Trench. There's some awesome member photos in there. There's different kinds of rooms that you can chat in for all of your different favorite space companies, spaceflight in general, food chat, sports ball. It's all in there. So thank you very much for doing that, and we'll see you in there. Again, D, I'm amazed you had the track this long. Absolutely spectacular. And again, the word from ULA that everything proceeding as planned so far on their coverage of the launch. There is still the deployment, which should be ongoing right about now. And hopefully we'll get word later from ULA or from Amazon at the confirmation of all of those 27 satellites deploying. And then again, that will be followed at about 54 minutes into flight with one last burn of the Centaur upper stage, and that will help it to re-enter and prevent creating extra space junk. And we'll see that usually splash down probably off the Pacific, in the Pacific Ocean, kind of near Point Nemo, so basically in the middle of nowhere. But that will do it for our coverage here as well tonight. Max Evans, thank you for joining us from the field.
Pleasure as always, everybody. And thank you very much for coming to hang out with us during this ungodly hour of the morning, but for a rather special rocket to see fly nowadays. And we hope to see you again very soon.
And D-Wise will also be seeing your slow-mo in a moment, but thank you for rolling out too.
Of course, it's always a good day when you have a launch, and this morning was a very good day.
Absolutely. And I will make sure I mention Jay Keegan, who was the one pushing the buttons, pulling the lever. See, I didn't forget about you this time. I am Sawyer Rosenstein. I've been your host for this evening's broadcast. Thank you so much for watching. And of course, as always, we will see you all for the next one. For now, enjoy some slow motion replay.
And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Doubling up. Roger, Atlantic.
Tango down to nominal.
Fighting downside FD off. Bring in FD off. It's orange! Orange 45! Oh my god! Oh my god! Decollage! What is it? Put that in the big bag, Tingle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting in the flare, correct?